For our next session titled Space Sustainability, please welcome Charity Weeden, former NASA Associate Administrator, Office of Technology Policy and Strategy, for a fireside chat moderated by Dr. PJ Maykish, Vice President for Strategy at SCSP.
Good afternoon, everyone. Thank you all so much for being here with us throughout the length of the summit. We have an incredible period of time with really an incredible person. You may have seen Charity Weeden's background, but not only was she, as just introduced, a former NASA administrator for the Office of Technology, Science, and Policy, but she had a dynamic life as an Air Force officer that led her into space, that led her to think about space. And so, Charity, it's such an honor to have you here. Really look forward to the conversation. And I wanted to just begin by letting everyone get to know you a little bit. Beyond your bio, why did you care about space? How did you get into it? How did it come into your life?
Thanks, PJ. It's such an honor to be here at SCSP. And by the way, how was my catwalk? Was that all right?
That was. It was
okay,
good.
We can put model onto my resume
perfect.
now?
Yeah,
okay.
We're all feeling that.
Okay, great.
None of us have done it.
So a little bit of an odd way of getting into the space world. I was in grade school, and the Challenger accident happened. And instead of getting, afraid of the dangers of space exploration, I got curious. And it was that day I said, hey, I think I want to be an astronaut. So I go about my school career and do the best I can. And then I realized, by the way, Royal Canadian Air Force I entered after high school, and there weren't many Canadian astronauts at that time. They were brain surgeons, Olympians, and military officers. And so I thought, I don't think I'm ever going to be a brain surgeon, but I think I can be a military officer. So I joined the military when I was 17 and never looked back.
That's awesome.
So I did it.
Yeah, that's amazing. And then as an officer, you were really taken into very dynamic space situations, to include Cheyenne Mountain, which if anybody is not tracking that, that's the C2 facility that can take a direct hit, in theory, from a nuclear weapon. And you're doing all this as a Canadian officer in America, and this life ultimately leads you to the United Nations. So how about just breaking down for everybody who's here, it's a loaded term, space sustainability. So what does it mean in practical terms to you? How would you define it?
Right. So I was in Cheyenne Mountain as the Deputy Sensor Manager for the Space Surveillance Network in 2004 to 2007. The reason why I bring that up is that is the first time I really understood what space sustainability was like. In January of 2007, there was the Chinese ASAT test. And so this was, the talk of the community at that point of this debris in orbit that would be there for decades, if not centuries. And so space sustainability became somewhat of an ethos in my career. So let's define it here, or let's actually talk about what it really is. You can find a definition at the United Nations long-term sustainability guidelines. There's a document online, you can look that up. But I'd like to explain things in very plain terms. And it goes like this. The things you're doing in space today, you want to continue to do them, right? You don't want to do things in orbit today that are going to prevent you from doing things in orbit tomorrow or in the future. So this is a really clear concept of thinking longer term. And this is in the family of space safety, you'll hear that term, space sustainability, or space security, and mission assurance. This is all a family of terms that are meaning the same thing.
Okay.
So it's important to understand it's an and, not an or. I can conduct orbital operations and I can conduct them in the future, and future generations can conduct them.
Okay, fantastic. So there might be one classic realist in the audience that is wondering, do norms actually work in space? So what basically, at just a philosophical level, are norms in space? How do they work? Do they work?
So norms of behavior in space are really about what are our behaviors. right? What is normal to do? And I think General Raymond was talking about this a little bit yesterday, and the United States has been a leader in norms of behavior in orbit for quite a long time. 1995, the US had its own best practices to prevent debris. That ended up being a conversation at the International or Interagency Debris Coordination Committee, and they produced a set of guidelines. So a group of multilateral space agencies. After that, it went to the UN Committee on the Peaceful Uses of Outer Space. So you could see how the progress from norms
Started with best practices.
starts with best practices, starts how do we want to define them,
Yeah.
and then you bring along your friends and allies, you present it to the United Nations, and now it's a global norm. And as General Raymond said yesterday, why do we need norms? Well, one, it's better than doing nothing,
For sure.
right? Number two, they can lead to more binding agreements. True, right?
Yeah.
And then third, it's about values. And I think this is a good parallel to think of in the AI governance world. We need to embed our values in what we do in orbit, right? And not allow adversaries to embed their values in orbit and
Yeah.
lead the conversation. And so this is very parallel, I think, to the AI governance conversation right now.
For some reason, I just got a picture of the movie, if anybody's seen it, For All Mankind, like if the Russians hit the moon first,
Right.
would they have defined norms in space? And that's not the world we want. So if you take norms and you take a step up, let's now talk maybe about what does a framework look like? If we want space to be this cool shared space we're talking about where everybody can operate safely, what's a good framework in your mind? What does it look like?
Well, just like the AI community, the space community loves their frameworks and their playbooks.
Yeah.
Let me present to you a very simple framework. And consider a triangle. You picture it in your brain? And it's split up on the bottom. The bottom portion is a foundation.
Okay.
And the top triangle is split in half. That bottom foundation is space situational awareness. What is happening in orbit?
Okay.
It gets down to the space weather, right? There's charged particles zooming by Earth all the time.
Right.
That is space weather. We need to understand that phenomenon because it impacts our satellites. It's about where objects are in orbit. This is actually a lot harder to do in practice. There are 30,000-ish trackable objects in orbit. Now, they're all in low Earth orbit, just think somewhere between 100 and 2,000 kilometers. These objects are going pretty fast, 10 times the speed of a bullet, essentially.
That's a problem.
That's a problem, and so they have a lot of energy if they hit you.
Yeah.
So I talked about the trackable objects, which is like a baseball size and up,
Okay.
but there are about 1 million untrackable,
That's interesting.
but still potent
Like
objects.
a bolt or something.
Like a marble.
Like a marble size.
So think of a marble
Going that fast.
going that fast. It's equivalent of the energy of a 550-pound object hitting you at 60 miles an hour. We can't reliably track 1 million potentially pieces of these pieces of debris. This is about space situation awareness. Where's the debris? Where's my satellite? How do I avoid it? What are the other weather conditions in orbit that I need to be aware of? And so all this comes into space situational awareness.
So it's like the challenges of one element of the framework, SA.
If we can get that right,
Okay.
you're on to a great start. And obviously, not just the United States, but around the world, there's been SSA efforts, but they're balkanized right now. The US has its own, Russia has its own, Europe has its own. And so if you're going to encounter an orbital neighbor, what data are they using? What tracking service are they using? How are we going to connect with each other? Which gets to my second piece. So we're going on top of that triangle.
Yeah, please.
We've got the foundation set.
I'm there.
The next is space traffic coordination. Some people like to say management. Manage is more hands-on now. I used to fly in an aircraft. Air traffic control would tell you turn left, turn right, up, down. But it's not quite like that in space. There's something else that I used to do called do regard.
Yeah.
You go out into the open ocean
Yeah.
and, see and be seen, If you see another high flyer, like, hey, I'm over here, that sort of thing. That's sort of how it works in orbit right now.
Right.
But you got to communicate. You got to know which phone number to call, right? You got to be talking from the same data sheet.
But that doesn't exist.
It exists in pockets.
Okay.
It doesn't exist adequately if we're talking about a Chinese satellite, for example, right? And so that's a big problem. This is where norms come in. You should call up. You should have a communication line.
Sure.
You should turn right and I should turn right, right? Like just like the
Right.
two aircraft would normally do. So these are where norms can get baked in. These are behaviors. Space traffic coordination is about behaviors. Yes, there's going to be technology that goes along with this, but space traffic coordination is about the behavior and the norms. Third element, hasn't really been done until, say, last 5 years or so, and this is remediating the environment. We have 7+ decades of using low Earth environment or orbital environment as the trash bin. Launch it, it operates, mission done, cool,
Leave it there.
we're good. And it will just slowly, descend, and pieces of junk will occur. There are 9,000 metric tons of upper stage rocket bodies.
Yep.
These are massive.
Big.
Big things that they get cooked on one side and then they get cooled the other and then they explode and they create a whole bunch of other pieces and it's a big mess. And so what you want to do with remediation is the term. You want to remediate the environment. You want to perhaps grapple one of these large objects and deorbit it out of harm's way. Maybe you want to use a laser system to just give a little bit of a pressure on those little bitty pieces that we can't reliably track and get them out of the way. Just-in-time collision avoidance is another method. And in the future, what if we can recycle, repurpose, reuse objects in orbit?
So that's maybe how it pays for itself? Because the idea is who would pay for that, right?
Right. I like to think of these problems in 3 elements. And these 3 elements, they walk side by side.
Yeah.
You got the policy element, right? You got regulations, best practices, norms, etc. You have the technical element. I've got my robotic structure. I'm going to go grapple this thing.
Yeah.
But please don't forget the economic element.
Yeah.
Because that's where we are right now. Space is not just an operational domain. It is a domain of commerce. There is there's a profit incentive for satellite operators, commercial satellite operators, to behave safely in orbit. So the question is, at what point does the risk level increase in orbit such that it's worth the money to put a little bit to the side to reduce that risk?
Right. Okay.
The question is, what does that look like?
Yeah.
And no one wants to be in charge of spending money to clean up someone else's space junk, right? Would you want to pay for your neighbor's garbage removal? Probably not.
Right.
So we got to figure that out, and it'll be a really important thing to figure out as well.
So if I were to, before we jump into maybe how does commercial tech help this framework happen? And where do you see goodness and answers coming? If I were to just brief you back, at the bottom of your triangle, you've got situational awareness, and we would need the nations to coordinate their pockets of SA with each other somehow.
Sure.
And then on the traffic management side, you would need to be able to call out to people, so it's not just due regard. There needs to be some sort of ATC of some kind. And we know there's challenges there because as we explored this morning, China won't pick up the line even for stuff like collisions in South China Sea and other things. So we would need them to answer such a line, and it could happen. And then in the final world, it has to be economically viable for somebody to clean it up, right? So I let that dog hunt, as they say in the South, and you can see where that could happen if you overcome those. Where does tech help us? And you could use the triangle or not, but how does it help us? Where do you see solutions coming?
Right. Well, even today, there are commercial solutions for space situational awareness. Radar tracking from Earth, there's space-based situational awareness. And so people are hungry for this data.
Yeah.
And it's an important piece of data to feed into a common element so we can all use it. So it's in its infancy, but it's out there.
Okay.
There are companies that do this worldwide. What I want to focus on is the commercial and the industry importance of that second element of the norms and the best practices. Industry needs to be in the room where it happens, where these decisions are made of what is a norm. And for all the goodness that the United Nations does, it is a government-to-government body.
So industry's not there.
They can be invited.
But
it's not
structurally,
right.
They're not there.
Structurally, they're not there. So where do they go? They actually coalesce. Trade associations are great for this. Come together. Here's our document on best practices. This was like the thing du jour about 5 years ago. I lost track of how many trade associations and industry groups were declaring best practices in orbit.
Okay. Space
Data Association is a really good international organization that shares that data. Remember the communication piece of the data? SDA does that, and they develop best practices as well. So it's important for industry to be in the room because we're talking about $1 trillion space economy, the plurality, in fact, the large majority of objects in orbit that are operated are from the industry. And so we need to have industry, a multi-stakeholder conversation instead of just government to government there. And then the third piece, now I can get into my geeky side and say yes for robotics, so really important technology to make this all work, is rendezvous and proximity operations. Usually in space situational awareness, you want to keep two objects away from each other. Not so with RPO. You want to put them together and safely. And so this is a huge technological hurdle that we should all applaud whenever our companies are able to do this. Like commercial LEO destinations, they're going to need to have resources brought up. And so astronauts can thrive and things like that. That is a rendezvous. And so rendezvous and proximity operations is a core technology that we need to get right. And just think about the other uses of it. And I think Daniel was alluding to this, of if we want outside of our Earth-Moon kind of sphere, we're going to have to get this right, rendezvous and prox ops. You're going to have to be able to in-space servicing, assembly, and manufacturing. So debris removal, remediation, rendezvous is all part of that family of ISAM. So ISAM is a good thing for a technological advance right now. Yeah.
How does, apart from the commercial actor piece, where do you see the international relations or international cooperation happening, or what do you think needs to happen there?
Well, there's a long history of space and international community. Right? There's a 1967 international treaty, the Outer Space Treaty, which the U.S. helped develop, and it allows international conversations about everything about space, including space sustainability. And I was alluding to the Committee on the Peaceful Uses of Outer Space. That is the body, the UN body, for this conversation. Also think about in low Earth orbit, every 90 minutes, that object's going around and around, you need ground stations. You need international ground stations, unless you just want to catch one signal every 90 minutes, which is not good enough for a lot of operations, right? So you're going to need to have that international collaboration for that piece. Spectrum management is another big, international collaborative opportunity here. And I talked to you already about the norms. So that's international. We're talking the entire Earth. But what if we have our best friends and allies, and we have the same values, we have the same norms, we share technology, we're interoperable, we're helping each other in the data pieces of this as well. That's where I think we need to keep our foot on the gas with our closest friends and allies and keep pushing forward on what we feel space sustainability norms should be. There are many examples of this. There's something called the Combined Space Operations. It's a military space kind of group, Five Eyes plus Germany, Japan, France. And they come up with as part of it, our norms of behavior in orbit and a vision together. So that's one example out of many out there of multilateral organizations helping.
Yeah, so I feel like the progression you're laying out is that everyone gets their own best practices together. You can multilateralize it, like with the combined space ops, and then maybe international. From there is sort of the progression you would see?
Right. Get your own house in order first, I always like to think, right?
Yep.
No one's going to listen to you if you're not
Organized.
like doing the thing that you're asking them to do.
Right.
You know what I mean?
Right.
And that's all about the leadership role as well. That getting the values out there. So it's important, and the U.S. has been a leader in this, and should continue to keep its foot on the gas and be a leader in norms of behavior.
That's fantastic. So with the time we have left, maybe just talk a little bit more about emerging tech in this space. Like, what excites you in this space?
Well, so I think it was also discussed before, but everyone's heard about spin-offs, space and technology and how we use it here on Earth. I think we need to start having an annual book on spin-ins because there's so much going on in AI and quantum technology that we need to be using to accelerate our progress in orbit. Let's take AI, for example.
Sure.
Right? Big data problem, right? Like, how many satellites can you manage at once? We're beyond the threshold right now. We need autonomy. And space specifically, with the distance involved and the communication lines that are required, you're going to absolutely need to leverage AI systems to locate the best landing area or what have you, whatever the mission is. And so AI is really important to that. But as someone who loves technology policy, and I want to accelerate the good but mitigate the bad, I want to also know what are those potential harms. What could go wrong of leveraging AI systems in deciding if we're going to maneuver to avoid a collision in orbit. Right? How are we going to make sure we have the right data, the right training? How are we going to overlap the norms? And those norms are going to change, right? And so it's an open question for the experts out there. Come talk to me after. I want to talk to you about how do we bake in norms into AI systems so that satellites can do good things.
On your emerging tech examples, I always think you were an aviator and you trusted what worked. So you're in a P3 and you trust it when it works, and so it would be neat if you could see AI work for SA and everything up on your pyramid, right? That would be, once it works, people will trust it, I think.
Right, and the space community is fairly risk averse. You're going to test on the ground as well. Here's where, tabletop exercises and integrating this into, again, the international community or the multilateral community. How are we all going to make decisions? Where do we need a human on the loop for these decisions? All that can be worked out on the ground as well. So there's lots to do here.
Right on. So how about where you see sort of lessons, right? So does history work here at all? Are there things that come to your mind where there was a Wild West somewhere that got tamed and it works today?
Well, there's a couple things, analogies we can use. I know some folks have looked financially, like how does nuclear power plants decommissioning, like these large-scale projects, and how can you afford to decommission them? That's one thing to look at. Maritime salvage is another question. There was a movie called Space Sweepers, by the way, on Netflix. I would encourage you all to watch it. It's a South Korean film, and it was all about the salvage business in orbit. It was pretty cool to watch. I'm like, oh, that's neat.
Cool.
And so, there are a couple things out there, but space is unique, space is hard, and so we need to get the right, we can't just map something that we've done here on Earth to space. You're going to have to adjust.
Okay, so it doesn't exactly translate.
Right.
So opportunities, maybe just for the whole room before you get off the stage, what do you think are sort of the opportunities to create the world that you're thinking about, the framework that you laid out? Like, in some sense, if you could put your strategy hat on, what should we do?
So you've heard the term boil the ocean kind of thing. Like, I don't like to boil oceans. I like to take it piece by piece, right? Because engineering, it either works or doesn't. Finance, you either have red or the black at the bottom of the line. But policy, how do you know if that's worked? How do you know if you've been successful? So I like to move needles.
Yeah.
And if you want to do something today, figure out that communication piece between operators and make sure that's solid. The second thing I want to see in the future is this data-driven approach, right? Let's get the space situation awareness all set up. Let's do that. Let's do that right. That's so fundamental to all this. And then third, let's drive forward on ISAM. In-space servicing, assembly, manufacturing. There's going to be a world of benefit out of that. I'll just put a bug in everyone's ears as well. Lunar is here, right? Lunar orbits are wacky. We can't track things very well around them. And so
So like collisions.
The potential collisions, it's called a conjunction when they come close to each other. There have been conjunctions in lunar orbit already. So I'm thinking of, horizon stuff here, where we need to start thinking on the lunar sustainability side as well.
Fantastic. Amazing. Really, it's so great to hear your thoughts on how this world gets created. I want to thank you personally for your role in it, because you've really had an interesting role in it. So all of us, thank you for your service, both in the military, out of the military. Everyone, would you please thank Charity Weeden with me?
Thank you.
For our final